everyone.
Hello, everyone. Good afternoon. I'm super excited to moderate this conversation between two leaders who are really shaping the future of AI. First is Dr. Andrew Ng, my former PhD advisor at Stanford. You've been democratizing AI education for over a decade, over 2 decades, I believe. And Dr. Lisa Su, AMD CEO, you've been leading the charge in making AI hardware available to a broader market of builders and more open, so more developers can contribute to the important software for AI compute. So let's start with something that's core to both of your missions, AI accessibility. Andrew, you've taught millions of people about AI through your courses. And Lisa, you've built compute that's served millions of people. As leaders in making AI more widely available to developers, what do you view as key levers in making this happen and ultimately accelerating AI progress effectively and safely?
Well, first of all, it's the first time I'm sitting with this audience, so I have to say, are you guys having a good day? It is super important to me that you have a good day because you really are the center of our world in terms of this whole concept of democratizing AI. Our goal in life is to make sure that there's an incredibly strong compute roadmap, but more than that, it's a compute roadmap that everyone can have access to. And what does that mean? Okay, that means lots and lots of places where you can get compute, but it also means a very strong ecosystem. And the developer community is really at the center of that. So that's very high on our priority list. That was a very important key thing that we wanted to do today, was to make sure that there was number one, Anush, that developer cloud better be working well.
Woo!
No pressure, but that's what I said to Anush. I said, look, I love the fact that we're going to announce a developer cloud. I want to make sure that when all of you access it, that it does in fact do what you say. But look, we want to give you lots and lots of compute. That's our goal in life, and it's really a pleasure to be here on stage with Andrew, who's done so much for AI. So I'll turn it over to you.
No, thank you. Let me share something about so this is what I think of as an AI stack, right? Lowest level semiconductor, AMD, NVIDIA, and others. Hyperscalers or the large clouds built on top of that. Then the AI foundation model companies like OpenAI, Anthropic, Gemini, and many others. And then I think the majority of people in this room, really the majority of people in the world, will be working the application layer, where we take advantage of the wonderful tools at the technology layers, be it semiconductor, cloud hyperscaler, or foundation model, to build wonderful applications. And in fact, I spend a lot of my time with the application layer, and almost by definition, even though a lot of the PR and hype is at the technology layer, the application layer has got to be even more valuable because, frankly, we need the applications to generate more revenue, so that they can afford to pay the technology layers. And frankly, one of the reasons I really appreciate Lisa and Vamsi and the AMD team's work is this approach to openness. And maybe to make an analogy, if we look at the mobile ecosystem, frankly, is like kind of it's just not that interesting, right? And one of the reasons is because—
By the way, Andrew said that. I didn't say that.
My bad. And one of the reasons is there are 2 gatekeepers, Android and iOS, and unless they let you do certain things, there's certain innovations they're just not allowed to have, for monetization, innovation, and so on. One of the fears in AI has been the rise of gatekeepers at some layer of the stack that ends up, capturing unfair amounts of rent, and also, frankly, stifling innovation. So at the foundation model layer, I think supporting open weight models has been absolutely critical. There are definitely AI foundation model companies that did intense lobbying to try to wipe out open source, because it would have been great if some of them could be the gatekeeper. I think that threat one still there is diffuse, and for all of us, the application layer, we want that layer to be open. If you look at the other layers of the stack, I think the semiconductor layer is one where there is clear potential for there to be gatekeepers. And I think in contrast, the very open ROCm ecosystem and making sure that developers have choice in semiconductor, that's what prevents gatekeepers from arising that would then force application developers to have to get permission from someone else or to be allowed to innovate in whether we want to. So I think that because of that, I actually really appreciate a lot of the work that Lisa Vanzi, Rockham team, and really the broader AMD team is doing.
Thank you, Andrew.
Can you touch on an example of an application that would be affected by that type of openness? And then, I don't know, Lisa, you could touch on how the infrastructure underneath could support that if it were open?
I think right now, maybe it's actually so clear in mobile. It turns out that you can't, launch a new keyboard. It's very difficult to launch a new map app. You can't launch a new voice assistant in the United States because of the gatekeepers on mobile. It's very difficult to do some of those things. I think that the Gen AI world is still, younger and earlier. And so I think where gatekeepers who choose to stifle innovation is because the gatekeepers have not had the power to stifle innovation. I think it's been a good thing. I think, for example, if none of us were allowed to find two models, because there were gatekeepers that chose to let us only prompt their models or had to fine-tune all the infra, I think the open innovation ecosystem is really powerful. Or I was actually really interested to see within a few days of the latest DeepSeek model being released, it was already distilled on top of Qwen. I think the DeepSeek team did it, but that's two open models, DeepSeek and Qwen, being distilled together to form a new model. And I think there's so many innovations. And I don't know, when Llama was released, some people thought the context length was too short, and then some folks rejiggered a new version of Llama, longer context window. So there's so many things that's very difficult to sit down in advance or train an adapter to take a text-only model and have it also input images. So there's so many things that openness has already enabled at the foundation model layer. And then also having the semiconductor infra and the kernel support and so on to support that next layer of innovations. I feel like it feels really important to me.
Yeah, actually, Andrew, I completely agree with you. I mean, I think we were really actually impressed with just how fast innovation was happening, around, DeepSeek and around Llama. I mean, the fact is, day zero models, they work on, a whole bunch of infrastructure. It was very easy for our team to optimize, actually very easy to optimize. And then, frankly, people were moving things over. And, whether you use the model itself or you just took pieces of it, you were able to really improve the infrastructure. I think from our standpoint, from an infrastructure standpoint, I have to say that sometimes, it is actually scary for us to open source stuff. And, Vamsi and Anush can vouch for that because it's not perfect. And the idea is when it's not perfect, you guys will all see it and you'll say, well, this is not right and this is not right. And frankly, I think the whole model of open source and an open ecosystem is for us to trust that, yeah, it may not be perfect, but by the fact that we're willing to open it means that it will get much better, much faster with different ways of doing things and different capabilities. So certainly the silicon layer, we have to innovate as fast as possible. It's very, very complex. But in terms of ensuring that the amount of work you have to do on the upper layers is as minimal as possible, and it just ports right over. I mean, that's the whole idea, so that you have choice in what you do. And we're very committed to that. We're continuing to build out that ecosystem. It is not perfect, but it's getting a lot better. And with the power of the open ecosystem, I think just some of the great results that we've seen so far, like MI350 is relatively, if I can tell you just how many systems we have internally, we've delivered some to some of the key open ecosystem partners. The fact that it's actually come up so well in terms of performance, I think has a lot to do with the fact that the ecosystem is open and is able to do that. So yes, it's a very important part of our infrastructure, and we'll continue to build that out.
Awesome.
And let me just say, but AMD isn't paying me, right? I don't work for AMD, but I think I found that some of my workloads written in PyTorch, ported over to AMD, not all. I wish I could say everything I ever did ported seamlessly over to AMD, but a large fraction when we tried ran with basically no code changes when implementing PyTorch. It doesn't work all the time, but I think if you have access to Dev Cloud or some AMD GPUs, it might be worth try running it on AMD. Maybe it won't work, but I think there's a decent chance it will if you implement the PyTorch layer, and then do your TCO back of the envelope price performance calculation, and then decide what you may or may not want to do.
We're definitely not paying you, but we are super happy.
Maybe you should.
Negotiating on stage, I see.
Yes. But we're super happy that you're here because you have so much credibility with. Look, it should work. I mean, it should work. That's the bottom line. It absolutely should be a very easy port.
Yeah.
How should developers in the audience get more involved as we open more and more parts of the stack? Andrew, you mentioned that people are very involved in increasing the context window of Llama, for example, or at that model layer. But wondering at the lower layers, how should people get more involved?
Yeah. So I think many of us operate in many layers of the stack. I feel like for the people here, which I think is going to be in the minority, operating close to GPU at the kernel layer, I think it's worth really taking a look, right, at open ROCm ecosystem and seeing there's a way to support more open things. I think that for teams working higher up at the stack, frankly, most of us would rather just, frankly, not have to care and do a price performance calculation, and then hopefully be able to access, whatever compute service gives us the best price performance. And I think that just to touch on the higher level of the stack, I think the opportunities at the application layer are just amazing. So I think of two things as having happened in the last couple of years. One is the rise of AI building blocks. So the tools for prompting, evals, RAG, vector databases, guardrails, agentic workflows. These building blocks are amazing, so that it's now possible to take these building blocks and combine them really quickly to build applications that just were not possible 2 or 3 years ago. So I think for those of you operating the application layer, go learn about all these wonderful building blocks built on top of whatever is a compute provider. And then the other exciting thing is AI-assisted coding, right? Like many of you, I personally can't imagine myself ever wanting to code again without AI assistance. And the evolution of the tools for AI coding assistance is one of the, I know we're supposed to say everything in AI goes so fast, but frankly, I think the pace of innovation in AI coding assistance is one of the fastest in the sector that is already very fast. So 2-3 years ago, was it 2002, GitHub Copilot did a good job pioneering code autocomplete. And then there came the Cursor Windsurf generation, which was much more sophisticated. You could write code. The agentic workflows there kind of worked, sometimes introduced a lot of bugs, but kind of was making good progress. And then there's a new generation of even much more agentic AI coding assistance. So Claude 4 was released like 2.5 weeks ago, and I found myself in the last 2.5 weeks using Claude Code a lot. Some of my team members also playing around with Codex, and I think these highly agentic AI workflows are going to be a huge boost to developer productivity. And part of me wonders also, is this going to help with kind of the, CUDA, ROCm code translation or things as well, GPU portability. But I feel like as developers staying on top of these trends, I think this is already helping to maintain legacy software. But where I spend a lot of my time is, frankly, building quick and dirty prototypes. So my team AI Fund, we built many startups, and I find that when you, as a developer, have an idea, there's so many things that I or my team will implement in an afternoon that a few years ago would have been like 6 engineers and 3 months or something. So now I find that when there's an idea I get excited about, it frankly takes me longer, right, to explain it to someone else and get them to try to implement it than to just build it myself. And it's been interesting to see the incredible fast pace of iteration where we build a prototype in a day, get user feedback like that evening, and the next morning we're off to the next iteration. So I think that one thing I see is previously, people used to have angst that a lot of proof of concepts don't make it to production because it felt like wasted effort. But it doesn't actually bother me. I feel like the thing I focus more on is driving down the cost of doing a proof of concept so low that if you can build 20 prototypes and 18 die a quick, quiet death, and that's the price of finding the two, they're really valuable. They want to take to production and take the scale. That's actually an excellent trade-off. So I find that the innovation process at both startups and large corporates is changing to take advantage of this capability of insanely fast prototypes as a mechanism for inventing, figuring out what will actually work. So I think all that is super exciting at the application layer, and again, comes back to ensure this excitement continues and that we're all allowed to continue to innovate with no gatekeepers, making sure the tech layer is relatively open will be an important part of continuing to support this application innovation.
I really like that concept, Andrew. I think this idea of rapid prototyping, so we fail fast, but we learn a lot, and that speed is very much what we're trying to do. I mean, certainly if you look at our evolution of Rockham, I think it's fair to say that even a year ago, we probably were much more focused on sort of the hyperscale environments. They buy lots of GPUs. These are large labs. And we learned a lot through our partners there. We very much appreciate our partnerships with Microsoft and Meta and OpenAI and these folks. But we also realize that the rate and pace of innovation that's happening in the startup community is like unbelievable. I mean, the kind of this idea of lots of people, great ideas, fast learning. And so we've really shifted our developer efforts to something that is much more let's get stuff out there quick. Anush runs this program for us. Every 2 weeks we have a new training Docker, new inference Docker that goes out. We do a good amount of tests on it, but obviously we don't get everything right. We get quick feedback. We make sure that we get that feedback and have it go into the next release. And frankly, the speed of that helps us learn much faster. And so back to your question, Sharon, about how to get involved. I actually think this notion of sort of the two pieces that Andrew said is exactly right. Like for the vast majority of you, like I never want you to think about it. Like think about this stuff should just work out of the box. If you're running on PyTorch or you're using any of these, let's call it higher level frameworks, it should just run on AMD. There are times when you need to do performance optimization or we need new kernels or some kind of kernel optimization. We're actually starting to, Vamsi's training AI to write kernels for us so that we can get that done faster. Actually, that's one of the things young lady is going to do here as Sharon and her team join AMD. But for those of you who are innovating and you have good ideas, I mean, we'll take that code and directly put it into our inference and training Dockers as well. That's kind of the very positive cycle we can get with a lot of people who are doing different use cases on our hardware.
I think almost a testament to it being so easy to use is seeing AI researchers creating the new architecture on AMD GPUs and running with that, or developers creating the new agent interface on top of AMD GPUs and scaling that out. I want to shift the conversation a bit to something that we were chatting about backstage around jobs and AI. Andrew, I think you mentioned that. I think people think about like, okay, this is automating a lot of the code I'm writing, and I spent a lot of my time writing code. So where does that go? But also, what opportunities does that open up?
So as early as earlier this year and certainly last year, there are a few people advising others to stop learning to write code because AI will automate it. I think we'll look back on that as some of the worst career advice ever given. Because as something becomes easier, more people should do it, not fewer. So I think when the world moved from punch cards to keyboards, right, became easier to code, more people did it. When the world moved from assembly language to COBOL, there were actually articles saying, well, we now have COBOL, programming is so easier, it looks like we don't need programmers anymore. But the opposite happened, right? And I think as we now have AI-assisted coding, a lot more people should be coding. And I think the demand for custom software has no practical ceiling. So the cost of software engineering comes down, which it is. We'll just get more and more great software out in the world. But software engineering is shifting. So there is a stereotype of, the fresh college grad that is a Gen AI native that is outperforming the much more experienced engineers. So I'll just be really straight and tell you what I see. It is true that a fresh college grad that is really on top of AI will outperform a full stack engineer with 10 years of experience that is still doing things they were back in 2002. 2022, right? 3 years before Gen AI, 3 years ago before Gen AI. But the other piece that is less well appreciated is the best engineers I know are not fresh college grads. No offense to fresh college grads. They're actually very experienced engineers that deeply understand architecture and the conceptual framework of how to think about computers, and additionally are on top of AI and on top of these AI skills. I know that one source of angst has been an uptake in difficulty of finding jobs of fresh CS grads. And I think one really unfortunate thing is many businesses just can't find enough skilled Gen AI application developers, people that know how to use AI coding assistants, how to use some of the building blocks that Lisa alluded to build really valuable applications really quickly. We just can't find enough of those people. But a lot of the educational systems, especially university curricula, tends to get updated slowly, are still not yet training people for these jobs that are very much in demand and that companies can't get enough of. So I think in the future, we will need a lot more software written, but there is a big upskilling challenge to teach developers, as well as frankly, non-developers to use these tools, which make them much more productive.
Yeah, I mean, I can tell you from our perspective at AMD, we are hiring a ton of people. So and we're using AI everywhere. We're using AI everywhere in our workflow, throughout our hardware work, throughout our software work, throughout our, sales, marketing, HR, all of these places. But the fact of the matter is, we still need more. So the idea that somehow AI is going to replace all of these jobs, I think, is just simply not true. For us, the real quotient is how do we get more products to market faster? Frankly, that's the goal. If I could do, a 3-year project and do it in 6 months, that has incredible value. Now, we can't necessarily do all of that, but we can certainly broaden the pipeline and do a lot more. So I think that says that there is back to this comment of the more AI you use, the more capable and productive you are, and the more we're going to be able to get from a engineering standpoint is certainly my philosophy. And this idea of sort of continuing education. I mean, Andrew, I really appreciate much of what you do in terms of just this whole notion of you don't just go to school and stop learning. You actually learn every single day, and you learn in different ways, right? You learn on the job, you learn through courses like much of what you're doing at Coursera, and frankly, we learn by forums like this. I think that's the key. I mean, the key thing is you have to keep this pace of learning up, and that's what AI actually helps you do, is to learn much faster.
Yeah.
So you both shared some really great perspectives, really strong perspectives. What should the audience take away, wrapping up a bit, what should the audience take away as a developer from this session? What's your call to action to each and every one of them?
To me, one of the most important life lessons is you're allowed to just do stuff. Right? Don't harm anyone, don't do damage, but so long as you're not doing damage to people and things, you're allowed to just do stuff. And I think in today's world, with AI-assisted coding tools and really amazing AI building blocks, the number of things that individuals can do, can implement has exploded. So I think this is just a wonderful time to go and build stuff. And so long as you're not harming anyone, you don't need anyone else's permission. You don't need anyone else to think your idea is a good one. Just go and build stuff. And then if what you build sucks, build it anyway. You learn the lesson, get user feedback, learn that it sucks, let it die a quick, quiet death, and then go build something else. And I find that a lot of my best projects, including, frankly, Coursera starts off as a side project. It actually felt like, boy, I'm a Stanford professor. Back then, I thought, I'm a Stanford professor. Am I allowed to be spending time doing this weird online educational stuff that no one cared about? But I thought, all right, I'm just going to build it at home. And I think a lot of the best projects I've seen across Silicon Valley were these weird things with someone without asking for permission, but still being responsible, right? Just went and built something, and a lot of the times it dies a quiet death, but even when it does, you still learn, and then sometimes you could be the one to build something really amazing. So I would say it's easier than ever before to build amazing things. Just go and build.
That's great. And I'm going to be really simple. Take what Andrew said, build, and build on AMD. Just give us a shot. And look, I want to really, say that when we say developers are really the center of, what we're trying to do with ROCm, we really mean that. And it is AMD is very much a learning culture. We understand, I like to say we're at the very early innings of AI. As much has happened over the last couple of years, just imagine what the next 5 years or the next 10 years are going to be like. We're just at the very beginning, and we're in this ecosystem. We have a chance to kind of write the page on what's going to happen in the future. That's a great place to be. So we want to be your partner in that. We want to be an enabler of that, and we want to learn from you and really help you learn as well. So again, thanks for spending some time with us today. Thank you, Sharon, for moderating. Thank you, Andrew, for participating. And I think we have a lot of great things we can do together.
All right, thank you both. Please join me in a warm applause.